Britain's rapidly developing nuclear power program has, within a period of 10 years, placed her in the forefront of the world as designer and manufacturer of nuclear power stations. This is especially true in the case of the type using large gas-cooled graphite-moderated reactors, the vessels of which contain well over 1,000 tons of steel and are up to 4 inches in wall thickness. In order to produce reactor pressure vessels economically and to the highest possible standard, the largest size plates manufactured by the steel mills are needed, the forming of which require presses outside the capacity of those normally used in this country today. Fielding and Platt Limited, as specialists in the manufacture of heavy hydraulic equipment, were commissioned by Whessoe Limited, Darlington, to prepare estimates and design specifications of a press that would meet present and future requirements in the forming of steel plates for reactor pressure vessels. The need of such a press was well known to Whessoe, as they were the manufacturers of the first 8 large reactor pressure vessels for nuclear power in Great Britain. To ascertain the maximum press power, small-scale experiments were carried out at Darlington and Gloucester. Here at Fieldings, mild steel plates were heated to about 950 degrees centigrade and formed in a 150-ton open-gap press. The chief designer and his colleagues controlled the tests and discussed their findings, at the same time comparing them with the results of experiments carried out at Whessoe. With a reduction of 8:1 on die and plate dimensions, a series of pressure stroke curves were obtained for steel plates of different thicknesses. From the combined experiments, it was finally agreed that a maximum of 4,500 tons capacity was needed, which also provided a margin of ample power for future development. With the placing of the order, the production drawing office commenced the detailing of components. In addition, a scale model was made to help with the erection and plant layout, including the furnace and furnace charger. The press is of the 8-column multi-ram 3-table upstroking type. The construction and proportions of the main units, especially the mild steel tables, are extremely large. The bottom table was built by Dorman Long Limited, Redcar, and the other 2 were ordered from William Beardmore Limited, Glasgow, one of the few works in Europe capable of manipulating such units. Stress relieving of all the tables was carried out under a carefully controlled procedure. Here is seen the massive heating pit in which the 2 tables were treated. Even at Beardmore's, the task of transporting these 110 and 120-ton loads about their own works was considerable and required the specialized knowledge and equipment of Pickfords to carry it out. The method adopted for fabrication by the Anglo-Swedish Welding Company, who were given the task of welding the fabrication at Beardmore's works, was to make a honeycomb of the webs and stiffeners, machine top and bottom, and then weld on the heavy flange plates, which themselves had to be machined flat. This enabled a very satisfactory close fit to be made of all joints, a most necessary condition in this type of weldment. To ensure that the welding procedure was strictly adhered to, Lloyd's Register of Shipping Land Division was brought in both at Glasgow and Redcar. Back at Gloucester, a wide variety of components were being manufactured in the machine shops and part-assembled in readiness for dispatch to Whessoe. As much of the pipework as possible was prefabricated at Gloucester, thus reducing to a minimum the amount of pipe bending necessary on site. Fielding H3 type 3-throw pumps, the main source of press power, were given the usual thorough tests before being dispatched. At Darlington, work was going ahead on the 39-foot deep press foundations, before the completion of which more than 2,400 tons of earth had to be excavated. The concrete was heavily reinforced to accept the 950 tons dead load of the press. The route for transporting the completed fabrications had to be meticulously planned, as each of the press tables weighs over 100 tons and is 27 feet long and 17 feet wide. It was decided to ship the top and moving tables from Glasgow docks, down the coast, and up the Manchester Ship Canal to Salford, from where they could be unloaded and moved by road across the Pennines. This method of transport was necessary due to the construction of roads and bridges between Scotland and England, which were unfortunately not capable of carrying loads of the weight and width of these fabrications. Detailed notifications of the road route had to be sent to the local authorities through whose area the load was planned to travel. This procedure is carried out to enable a check to be made of any damage to road facilities resulting from the passage of such heavy loads. Police cooperation was necessary to provide escorts through congested areas and also to set up checkpoints on bridges and corners that were difficult to negotiate. The crews of the transporting vehicles operated as a closely coordinated team, and therefore the two drivers were in constant touch by radio telephone. The time taken to transport the tables from Glasgow to Darlington was 5 days, 2 days of which were spent at sea. In the new press shop at Whessoe, crane facilities to handle the tables were not available. Therefore, slipways had to be erected to remove the tables from the low loader. The components were therefore virtually manhandled into position at each stage of erection. As the components arrived on site, Fielding's team of skilled fitters and erectors, working in conjunction with the staff of Whessoe, assembled and prepared the press for operation. When the top table and columns had been placed in position, the table had to be lifted until it could be supported on the steel half collars housed in recesses machined in the columns. This was achieved by operating the moving table at low pressure and using it as a hydraulic jack. The time taken to design and manufacture a press of this size and also prepare the site for the installation is unavoidably long. And it was not until a period of 3 years had elapsed after the first inquiry that the contract was finished and the press ready to operate. The press has 11 main rams and 17 ejector rams operated from a central control position. The control desk has been designed to ensure ease of operation and give full information of the press operating conditions. Movement of the bottom table is controlled by the 3-positional hand lever, whilst the power applied is automatically selected by the ultimate power selector switch. The ejectors are operated by joystick-controlled valves. Here is shown the selection of 3 ejectors, followed by the whole group of 17. Before the press was handed over to the Whessoe Company, initial tests were carried out at a reduced press power using relatively small plates, 10 feet long and 4 inches in thickness. Before being formed in the press, the plates are rough flame cut to allow clearance for final sizing. All scale is removed by flame cleaning and superficial imperfections ground out and welded. Here is shown a large 7-ton plate, 19.5 feet long and 7.5 feet wide, being loaded onto the charger and into the soaking furnace. The plate is heated to a temperature of approximately 930 degrees centigrade for a period of 3 hours. hot plate is withdrawn from the furnace and lifted by the ejectors off the charger and then lowered onto the dies. To prevent the plate temperature falling below a predetermined point, the complete pressing cycle must be carried out with a minimum of delay. The time required to press a plate of these large dimensions is less than 1 minute 50 seconds, inclusive of the period when it is being withdrawn from the furnace. On completion of the pressing stroke, the plate is still in a plastic state. To prevent further movement, it is left on the dies for a period of 2 hours. When the plate has been removed, resetting of the dies is necessary. This is due to the amount of expansion that takes place in them during the pressing and cooling period. The irregular shaped plates do not give a balanced weight distribution on the ejector rams, and this results in an uneven movement on the upward and downward stroke. After forming, the plates are accurately marked off by a special method using a silhouette projector principle that was developed by Whessoe. The plates are then flame cut, during which process the mating edges are beveled, ready for welding. The furnace and furnace charger were designed and installed by Messrs. Gibbons of Dudley, which, in combination with a fielding press, provides one of the finest integrated plate pressing facilities in the world.